Sports medicine. So, the aim of this video is to provide an overview on wearable systems used in the sports medicines and physical activities. This sports concept covers many different type of activities. The use of the ICT technologies in the sports and in particular of wearable system is therefore closely linked with the speciality of the sportive practical rules, conditions, environment, and goals. Sports is an activity that is characterized by the demand of physical exertion. This is about sports. It is usually institutionalized, which implies competition between individuals or between the teams, and it is governed by a set of rules. Sports is also referred to as activities where the physical capacity, conditions, and trainings are the fundamental circumstances that are primordial determinants of the outcomes, such as win or loss. Nowadays, physiological conditions are of key importance, particularly in the high competition world where physical conditions are brought to the limit of human being capacity. More broadly, the term also includes activities such as mind sports, card sports, board games, or motor sports where mental acuity or equipment quality is major factor. Sports that are subjectively judged are distinct from other judged activities such as bodybuilding shows, because in the former the activity performed is the primary focus of evaluation rather than the physical attributes of the contestant, as in the later. Physical fitness can also prevent or threat or treat many chronic health conditions brought on by unhealthy lifestyle or aging. Measurement is substantial to the practice of the sports and fitness. Measurement of the outcome of the practice, such as time, distance, length, weight, height, and strength, as well as the result of the physical exertion, such as oxygen consumption, heart rate, temperature, or biomechanical measurements to be measured. Thus, a big number of measurement systems have been developed and commercialized for the use in almost all type of sports and fitness practices. A similar idea has been developed in order to analyze the grip force in sports such as golf, tennis, cricket, baseball. It's the sports for implementing bat, club, racket. Okay, where the participant need to use an equipment like bat, club, racket, etc. in order to strike a ball or a similar object. So in such type of sports, the only point of contact that the participant has with the equipment is at the grip. Okay, so balance must be found between the force used to secure the object in the hand and wrist range of motion. Furthermore, grip and pinch strength vary based on wrist angle. The measure of the grip force during a standard golf tee shot is done using two different measurement techniques. The first utilized a matrix type thin film sensor applied to a golf grip. The second method involved individual thin film force sensor strategically placed on two golf gloves. In this case, the system is built using a pressure sensor by TechScan using piezoresistors. As a result, it is found that the force produced by an individual golfers were very repeatable but varied considerably between golfers' force. Such investigation of grip force can aid in future grip design. The creation of training aids, injury evaluation and prevention and answer existing questions about how elite players actually grip the club. So this figure in the left hand side represent a golf grip matrix sensor, and these are the photographs which are taken from the reference Komi 2008. Okay, so these are the different types of or the gloves which having a sensor in order to evaluate whatever we are going to analyze. The technology used for monitoring such vital signs from athlete while practicing sports is focused on the measurement of HR using a sensor which is located on the chest. The simplest case and most used is a band that transmit sensor data signal to a wearable receiver, that is a wireless wrist computer watch. Monitoring heart rate during exercise is especially useful in endurance training, professional training, planning, or fitness workouts. Maximum oxygen intake and energy expenditure can be accurately estimated from heart rate measurement. Heart rate monitoring is in real time during training allows a user to control his training intensity accurately to optimize training and to avoid too low or too high training loads. The original idea for wearable HR monitoring dedicated to sports came from cross country skiing training in the late 1970s. In 1983, the first chest strap wearable heart rate monitor was produced by Polar Electro. This device consisted of two parts, a watch receiver and a transmitter on an ECG based chest strap. ECG based chest straps are widely used for monitoring heart rate during sports. Chest strap based heart rate monitors provide relatively accurate monitoring of heart rate, but they suffer from reduced comfort from the chest strap, especially for female users. Optical monitoring of HR has been recently introduced as an alternative to overcome especially the usability and user acceptance related challenges in chest strap heart rate monitors. Optical monitoring of HR during sports may be done from different body position including ear, forearm and wrist. Most of the commercialized devices use a green light source, one or several LEDs combined with a single photodetector. It has been shown that green light has a better signal to noise ratio for AC component during movement than longer wavelength. This table gives us the characteristics of two typical devices designed for sports based on optical HR monitoring. HR means heart rate, namely the Sochi's rhythms and Myopes alpha. Let us see the features of these two. First feature is the source light color and LEDs. In Sochi's rhythms, it has two infrared LEDs. In Myo Alpha, it has two green LEDs. The number of photodetector used in Sochi's rhythm is 1, and for Myo Alpha also is the same. The location is on forearm in Sochi's rhythm and wrist in Myo's Alpha. The band type they used here is textile one, and here Myo Alpha is plastic rubber. The wireless connectivity, the technology they are using in Sochi's rhythm is Bluetooth, and in Myo Alpha is Bluetooth or ANT plus. Data storing is here there is no memory is used in both the devices, and the display is there is no display in Sochi's rhythm, and dot matrix LCD is used in Myos Alpha. So let us see the picture of these two company, Sochi's rhythm and A is Sochi's rhythm, and B is Myos Alpha. So let us see the result of the good quality experiment and poor quality experiment result. So A is a good quality experiment result. You can see the reference of the ECG. ECG is used for heart rate. It is you can see in the y-axis heart rate beats per minute, and the dark one is a reference one, and dotted one is a forearm located rhythm, and next one is a wrist located alpha. So you can see there is no difference between these two, right? It is more or less similar to the reference. So for both the forearm and wrist, we get the accurate somewhat a good result, right? But you can see in the graph of B, it is between heart rate and time. The forearm and wrist located alpha vary significantly, varies much compared to the reference. So it is a poor quality experiment. So you should not use that devices, right? So next one is optical heart rate monitoring from forearm and wrist location during cross country skiing as compared to the chest strap ECG system. Okay, so you can see the reference one. There is dark one is a reference one, and dotted one is a forearm located rhythm, and next one is a wrist located alpha. So next one, the conclusion. Okay, so the technology used for monitoring the vital signals from athletes while practicing sports is focused on the measurement of the heart rate using a sensor which is located on the chest. The simplest case and the most used is a band that transmit the sensor data to a wearable receiver, that is a wristwatch computers. Alternative to this, basic sensor system is now offered by a smart sports cloth that are opening a new opportunity for physiological parameter measurements by including other vital signs such as respiration, body temperature, ECG, and motion monitoring. Measurement of the performance is of similar interest for athletes, both during the training and during the competition. There are wearable instruments for this purpose for almost any kind of sports practices. We have identified some of examples such as cycling, running, golf, swimming, underwater sports, or skiing. But it is far to be completed list of experiments offered in the professional sports market that meet the practitioner's necessity. Finally, the last group of measures that can be taken are the biomechanical measurements, which allows a sportsman or sportswoman to detect wrong movement in their practice and help to correct them and improve their styles, which avoids possible injuries. Actually, this field is the most experimental one and it is a subject of further research. Some of my reference for making these videos I have given below. First one, Annalisa Bonfiglio and Dilo D. Rossi. Wearable monitoring systems, Springer 2011. Second one book is Gong Zong Yang Body Sensor Network, Springer 2006. Third one is Fundamentals of Internet of Things, IoT, and Wearable Technology Design, IEEE Plus, Willy Higher Road. Fourth one, Wearable Sensor Fundamentals, Implementations, and Applications, edited by Edward Sasunovo, second edition. So, thank you for listening to this video. Thank you, Ananda.